In question 5a, we're to state what is meant by an ohmic conductor. Well, this is where current is directly proportional to potential difference, as the resistance is constant. In B part 1, we're to draw a suitable circuit diagram to determine whether a component is ohmic. We would need a power supply, we'd need some means of varying the voltage and therefore the current, we'd need a voltmeter across the component, and an ammeter in series with the component. In part 2, for the circuit diagram we've drawn, we're to describe a suitable experiment, including the measurements we would take, how we'd use the measurements, and how we'd reach a conclusion. Well, we'd find the potential difference across the component with the variable resistor at maximum and minimum values. We could then decide on at least 7 evenly spaced values of potential difference, recording the current and potential difference for these settings of the variable resistor. We'd repeat these readings and take a mean, and then plot a graph of current on the y-axis, potential difference on the x-axis. The gradient would give us 1 over resistance, and should be a straight line through the origin if the conductor is ohmic. In C part 1, we're to state the principal property of a superconductor. Well, it has 0 resistance. In part 2, we're to state what is meant by the critical temperature. Well, the material will have 0 resistance at or below the critical temperature. In part 3, give one use of a superconductor. Well, they're used to produce the very strong magnetic fields which are used in MRI scanners.